Hey everybody, it's Mrs. C, and I am coming to you in a place where geometry meets algebra. It's called geomalgebra. I'm not sure what it's called. It's called the here and now, and it's what we got. Let's dive into it. Okay, so this isn't so much, aside from having an X, it's not really algebra. We're going to work our way up into the algebra, but first, we need to make sure that you got your basic vocabulary and your basic understanding of relationships of angles when you have what are called parallel lines. So if you notice here, we have parallel lines. It's even telling us, given that line M is parallel to line N, find the value of X. Now, just to recap your relationships, we're going to go through some of the basics, so please pay close attention. This is super important, and it really shouldn't be the first time you've ever heard it. I'm going to be going pretty fast here as a review, so if you've never heard this, you might want to go find another video that does more of an introductory to angle relationships. So these are called angle relationships, parallel lines with what is referred to, this line right here, is a transversal. So a line that cuts through another line is called a transversal, but when a line cuts through parallel lines, it creates special relationships. So this transversal T, and it's cute that they named it T, right? T for transversal, is cutting through parallel lines, which is creating special relationships between the M and line N. And so let's take a look at our first one. We have the X and the 117. That's my relationship. Those are called corresponding angles. I'm going to write it for you. Corresponding angles. And when you have corresponding angles with parallel lines, corresponding angles are equal, or what we call congruent. That's the fancy word. Corresponding angles are congruent. So if these are corresponding angles, meaning they're in the exact same place above on the first line as they are in the bottom line, meaning over here, X is in the upper right-hand corner, and so is the 117. If I was to ask you who corresponds with this angle, it would be this one. Let me give you another one. These are corresponding angles. Who corresponds with this one? This one. They're all equal to each other. And of course, the last but not least one, who corresponds with this one? This one. They're equal to each other. Whatever measure they are, they'll be equal to each other. They are called corresponding angles. Same thing, same setup. We have parallel lines M and N and cut by transversal T. But now we've got an odd situation. We have an X value here and a 17 degrees here. These are called alternating exterior angles. Oh my goodness, yes. So first of all, if you notice, if you did, and I said this was just a review, so I don't want to go into too much detail. If you drew shading in between the parallel lines, right? You would have the interior angles would be in the shade, and the exterior angles would be outside of the shade, making another pair of exterior angles, these guys, alternating because they're on opposite sides, right? The purple one over here, I'll go purple again. This is in the upper left. This one's in the bottom right. On the orange one, right, we did, this one is in the upper right. This one is in the bottom left. That's the alternating part of it. Alternating exterior angles are congruent or equal to each other. So are alternating interior angles. They are also equal to each other. So if I was to go and erase this shade, I'll just erase it all. My interior angles are my angles that are inside that shaded space. And so if I was to say, who is my alternating interior to that one? It would be that one. alternating interior angles are equal. And if I wanted to know who was alternating interior to that one, it would be that one. Alternating interior angles are congruent or equal to each other, just like the alternating exterior angles are congruent. All right, let's move to the next. Okay, these guys are actually, they're not alternating, are they? They're interior. They're interior. You've got the parallel lines, but they're on the same side. These guys are called consecutive angles. And it doesn't matter so much if you know what to call them. It just matters that you know the relationship. Now, do they look equal to each other? You got an acute angle X, and you've got an obtuse angle 123. They are not equal to each other. They're actually supplementary. Now, if you've looked at any of my other video, this is going to be named, I'm going to name this part 2, line relationships or angle relationships. And so if you looked at part 1, or the first one that I did, you would know that I talked about consecutive angles. And I said we'll get more into that when we get more into our line relationships. And here we are. We've reached that place. So these are called consecutive. Consecutive angles are supplemental. Supplemental meaning they equal 180 degrees combined. So if I wanted to know the value of X, I would need to know what its supplemental value would be to 123. So what would we do? We do 180 minus 123, and we would get the actual value of X, which I'm not really going into what the values of these babies are, because we're going to sauce it up a little bit. This is flipping algebra, not flipping third grade. So I'm just telling you that's how you'd find it. Let's do another one. Okay, what are those? What are those? Sorry, that's so 2019. But what are those called? They are inside, right? They're on opposite sides inside. Yeah, I heard somebody out there. You said it, alternating interior. What did I tell you about alternating interior angles? Yes, they're equal. They're equal to each other. So if that one's 76, its alternating interior angle is also 76. And just as a shout out to those of you that saw my other video, remember I talked about how do you know what the value of an angle that's opposite? It's vertical. That means this one is 76 also. And where is my alternating exterior to that pink one? Down here and on the opposite side. So you actually know that those are 76 also. You can use the fact that you knew that they were alternating interior. You can now use another one like vertical angles to bring it out even more and identify more of these angles. Just by knowing one, you can know all of them with a little bit of tiny little bit of math. Let's do another one. Okay, we've come to the place that I wanted to get to. Now that is flipping algebra worthy. Let's take a look at that. I'll zoom that in a little bit. Yep, that's algebra, right? So we're being asked to find the value of X. Isn't that what we always do in algebra? Find the value of X. And what we're going to have to do is use our understanding of the angle and line relationships to do something algebraically. Now, if I told you, let's just pretend for a minute, I'm going to come up here, that this was 120 degrees, this angle. What would this angle be equal to? Well, what do you know about two angles that come together in this pretty little half circle? They're equal to 180 degrees. They are supplemental. So you would take 180 and minus 120, and you would wind up with, did you say 60? That's correct. You would wind up with 60 degrees because 60 plus 120 gives you that straight line, 180. Well, that's no different than these. Now I just made those numbers up. I doubt that is going to actually be the answer. But what do we know about those two angles combined? They equal 180 degrees. That's not hard. When there are two lines, two angles together that equal a half circle, they equal to 180 degrees. So let's add them up and set them equal to 180 degrees. You have 2x plus 6. I'm going to do this off to the side. 2x plus 6 plus x plus 9. I think it's just easier to add them up this way, right? I've got 3x's plus 15. That just seems a little bit nicer than laying them all in next to each other. 3x plus 15. You can do that as long as you combine like terms, please. Don't do anything silly and not combine like terms. And then let's solve for x. You've seen problems like this every day in algebra, right? Minus 15 from both sides. Okay, and then we'll subtract 15 from 180, so that's 165, I believe. I am without calculator right now. And that's 15. X is equal to 15. Does that look right? That is not 15. Let's do I don't have a calculator. It goes in, 3 goes in, 5. Oh, 50. Oh, goodness gracious, right? And that is 55. Not 15, 55. Okay. Sorry about that. Well, at least I caught it, right? 55. And so x is equal to 55. X equals 55. We could figure out what these actual angles were equal to. That's a really great check step. If x is equal to 55, then this angle is equal to 55 plus 9. So that would be 64. And then if x is equal to 55, 2 times 55, right? 110 plus 6, that's 116. And then 116 plus 64 would have to equal 180. I'm sorry. It is. If I can write the proper numbers down. That's 8, 1. Okay, 180 degrees. That's a good check step, guys. It didn't ask me for the measure. A lot of times it will just ask you for the measure of the angles, but it just asked for this. So the answer is x is equal to 55, but if you plug them in, you get two values that do add up to 180. So it's a good check step. Let's look at the next one. All right, what are these called? I'm going to give you a second. What are these called? These are called corresponding angles. And it doesn't matter so much if you know what they're called, I'm going to be honest, as long as you know what their mathematical relationship is. Corresponding angles are equal. I mean, look at them. The angles look equal to each other. So if they're supplemental, they don't look equal to each other. If they're complementary, they don't usually look equal to each other. But these are equal to each other. And so we're going to set them equal to each other, right? Not set them equal to 180, set them equal to each other. Because why? Corresponding angles are equal to each other. So you would say that 2x plus 9 equals 7x plus 24. You just use your basic algebra skills to solve for these geometry questions. So we just minus the 2x, however you want to do this. We get the 9 is equal to 5x plus 24. We'll minus the 24. I'm working right through the middle of my problem here. Okay, so I got the 5x on this side. And what's 24? 9 from 24, 15. Negative 15. We'll divide by 5. And we get x equal to a negative 3. Okay, so I'm getting x is equal to a negative 3. Now, you can never get a negative angle, but you certainly can get a negative x. And then definitely you can't get a negative angle. So in your check step, even if you have a negative x, you better not get a negative angle. So if we plug in the negative 3 in for that x, 2 times negative 3 is negative 6. But negative 6 plus 9 is equal to what? 3. That's a tiny angle. That's like the smallest angle ever. 3 degrees? Okay. Let's see if we get 3 degrees on this one. That's just weird. Negative 3 in here. And 7 times negative 3 is negative 21 plus 24, also 3. Definitely not drawn to scale, right? A 3-degree angle is like a little tiny sliver. But it's a good check step. I guess they're not going for believability here. So x was equal to negative 3, and my check step, they were equal to each other. So that's always a good sign. What kind of angles are these? They're alternating. What kind? Alternating interior or alternating exterior? Interior, yes. Alternating interior angles are also equal to each other. So we get 4x minus 2 equals 9x minus 22. We'll solve for that one. I think I'm minusing my 4x again. You know how I roll. I like to keep my x value positive, so. Now a lot of you like to put your x on the left side, but not me. Okay, I'm getting a 20 equal to a 5x. Dividing by 5, I got x equals 4. So my answer, x equals 4. And because I don't have an answer key here, you see me, I continue to do my check step. If x was equal to 4, 4 times 4 is 16. Minus 2 is 14 degrees, another tiny angle. I'll see if I get the same answer here. 9 times 4 is 36. 36 minus 22 is 8, 9, 10, 11, 12, 13, 14. I got 14. That checks out. Very nice. What about these guys? What are they called? Touching each other. Sharing a side. They are called adjacent. Very good. Adjacent angles are not equal to each other. I mean, look at them. This one is acute. This one is obtuse. And oh, look at the little half circle arc I made when I did that. Half circle arcs are equal to 180. They are supplemental. And so together they will equal 180. I like to add them together like this. I just find you make less mistakes when you do it like this. So 7, 8, 9, 10, 11 x's. And we have 6, 5, 4. So together they come to 11x plus 4. I'm going to put that simplified version up here. I'll erase this. Give me room. And then we'll just finish up. Let's minus the 4 this time. I got 11x equal to, what's that? 176. Uh-oh. Well, the only reason I'm saying 176, is because that doesn't go in evenly. And I don't have a calculator with me. Did I do something wrong? I'm going to pause and double check because I don't have an answer key. Awkward. It does go in evenly. It goes 16 times. Why did I think it didn't? Don't know. So it goes 16 times, which makes me feel a whole lot better. I don't know why. It's not like decimals are bad things. X is equal to 16. And then my check step. Okay, so a quick check step. I don't know, a quick check step. I got to work with the 16. Ay, ay, ay. All right. 4 times 16 minus 2. What's 4 times 16? Are you wondering why I haven't gotten up and just gotten a calculator at this point? Yes, so am I. 64 minus 2 is 62. Oh, Lord. And then, okay, 16 times 7. 42, 7, 8, 9, 10, 11. 11 plus 6. Row. Okay, I'm good. I'm wondering if you're sitting there just wondering why I think something's wrong. And I'll tell you right now, it's because I forgot that we were dealing with supplemental angles. It is a little late right now, so I'm not firing on all cylinders, I think is the saying. We didn't do anything wrong here. It's just that they're not supposed to be equal to each other. These were supplemental angles. They're supposed to add up to 180 degrees. So when I came over here at my 16 times 7 and got on 112 and said, uh-oh, there's nothing to uh-oh about, not yet. 7, 8, 9, 10, 11. Remember, if this one is, oh, that's an eraser tool. Don't want to do that. If this is 64, or wait, was it 64 or 62? It was 62 because I had to subtract. So this one's 62, and this one is 112, but I didn't add the 6. Got to still add 6 to it. 6, 7, 8. So 118. So just to recap on, I think I need another color. I've got a lot of colors going on here. 4x minus 2, we did 16 times 4 because we think x is equal to 16. 16 times 4 was 64, and minus 2 was 62. So that measure, that angle would have equaled 62. And then the other one was 7x plus 6. So it was 7 times 16, which was 112. And then when you had to add 6, was 118. So this one was equal to 118. I'll go back to green. Together, they have 118. Together, these two guys are supplemental, meaning they have to equal 180 degrees. So here's the big reveal, is 118 plus 60, I got it, 2, equal to 180. You have no idea how much I'm praying that it is. It is. Just a side note, we were done way over here. X equals 16. All of this was a check step. Okay, I am terrified, guys. Flipping algebra is flipping terrified to do this problem because I don't want to mess up. Okay. These are alternating interior angles. Alternating interior angles are equal to each other. I don't know why I'm relieved that we're doing the ones that are equal to each other. So I don't think they're easier or harder. I just don't know. I feel happy about it. I'm going to minus my 5x. I'm going to get x minus 8 equals 14. And I'm going to add 8. I love doing math with you guys. X is equal to, I don't know. What's 14 plus 8? Is it 22? 8, 9, 10, 11, 12, 1 to carry the 1, 22. All right. X is equal to 22. Should I just say it is and not check? No, I can't do that. If X is equal to 22, let's check it out. They should be equal to each other. What's 6 times 22? 22 times 6. Is it 132? Minus 8. What's 132 minus 8? Is that 124? I think it is. We'll see. If the other one equals 124, then we'll know it was. Let's do 5 times 22. 110 plus 14. Thank heavens. It's 124. That means 122 is the right answer. Awesome sauce. Okay, let's do the next one. Okay, I want to say just forget it. At the rate I'm going, I really do. I want to say just forget it. Let's try it. Okay, a word problem without a picture. That's all right. I'll just draw a picture. Angle A and B are vertical angles. Okay, so I'm just going to draw 2 lines like that. These are vertical angles. So are these. These are vertical angles. Opposite angles from each other are vertical. And so I think I'm just going to get rid of some of the crazy. All right, it's telling me that the measure of angle A, let's call this one, it's got more space to write in, 3x plus 26. And angle B are vertical to each other. So this one's x plus 20. So this one's A and this one's B. It says A and B are vertical. If the measure of angle A is 3x plus 26 degrees and the measure of angle B is x plus 20 degrees, find the value of x. Well, vertical angles are equal to each other. You didn't even need to draw it. You just needed to know vertical angles are equal. There it is. That's all. And then we just minus the x. We got 2x plus 26 equal to 20. And then we're going to minus the 26. And we get 2x equal to a negative 6. We'll divide by 2. And we get x is equal to negative 3. Remember when I told you, don't worry about getting a negative value of x. Worry about getting a negative angle. Negative angle, bad. Negative x, not bad. So we got to test it out. Oh, sorry, that's too close to the top. Negative 3 there. Negative 3 there. All right, so we get a 3 times a negative 3 is negative 9. And a negative 9 and a 26 is going to be, I think, a 17. 17? Yes, 17 degrees. And then this guy, negative 3 and a positive 20. Yep. 17 degrees. That checks out. We got one. I hope one more. I'm going to say it's one more. Angle A and B are complementary. Let's draw that. Angle A and B are complementary. There we go. A is 2x minus 28. And B is 4x minus 14. What do you know about complementary angles? They equal 180. So if we add these two together, remember how I did it? I did it off to the side. Like that. I get 6x's. And I'm adding those same sign sums. So I get 42. And then I set those all the way over here. 6x minus 42 equals complementary angles 90 degrees. That's it. Just solve for x. Add the 42. Add the 42. We get 6x equal to 132. And then we're going to divide by 6 and pray that that goes evenly. X is going to be equal to, I just did it in my head, but I want to show you. 6 goes into that 2. 22. So x should be equal to 22. And we can double check that by just plugging in a 22 here and a 22 here and doing the math. So 2 times 22 is 44. 44 minus 28, right? And what is 44 minus 28? Well, I'm doing it, that would be 2, would be 30, 12, 13, 14, 15, 16. I think it's 16. And then 4 times 22 is 88 minus 14. Uh-oh. 88, 4 times 22. That's 88 minus, oh, these were complementary. I did it again. I keep forgetting they're not supposed to be equal. That's so bad of me. 74 and 16, they're supposed to be complementary. They're supposed to equal 90 degrees, and I'm looking at them, and they do. 74 plus 16 does equal 90. That means we go back to this, guys. This was the right answer. Oh, my goodness. That was a doozy. Just short of 30 minutes. I want to thank you for sticking with me. I want to thank you for laughing along with me. I hope you had a big kick like I did because, wow, geometry, get out of my algebra. That's all I can say. It just really, is it trigger? It triggers me. Yes, it does. It's tough. Okay, we did it. We made it. We made it, guys, to the flip side. Peace.